So we're ready to start looking at what you're going to be handing in for the first part of the assignments here. So as you know, this is divided into two sections, 1A and 1B. So the elements that are related to 1A are going to be anything that's chapter 1, and that's going to be the 1A practice problems and assignment 1, part 1. Okay, so these are the two that you would be ready to do for. Oh, hold on. Would it be possible to get pictures of the assignment questions until some of us gets the book? Yeah, I'll see what I can do about that, and I'll look at that. Yeah, I have no problem doing that. Okay, so let's take a peek here first at the practice problems. So I'm going to click on the practice problems. And what I wanted to do was to add a little bit more detail here so that you all know what's expected for each one of the examples. So our practice problems are worth 20% of our grade. Remember, it's a 0 or a 10, and it's my way of kind of making sure that you follow along, and it's your first experience of what's expected really of the homework. This leads into and helps you to make sure you have a little bit of experience being able to do problems like what the homework is going to be. So what I did here was there are 5 examples that we went over. The first example we did the last time we were together at the beginning of our lecture, we sketched a diagram for example 1-1. We just manually sketched it. We didn't do any CAD. So you just need to hand in that sketched diagram with the labels and such that we did. The second example that we did was 1.2, and that's going to be just an ACAD diagram, including all of the labels and such, okay? Then the last 3 that we did this evening was you're going to do the AutoCAD diagram for each one, plus you need to show me the mobility equation, okay, and calculate it out for each one of those. And I showed you how to do that as well. Then what I want you to do, and I have it highlighted here, or I have it bolded, you want to complete each sentence below at the end of the document that you create, or however you're going to hand it in. And I want you to tell me 2 things that you learned in this first part of module 1, so in module 1A, and 2 things that you feel like you might still need some additional practice to feel comfortable with. All right. And then lastly, just tell me what you think the main objective. I don't want you to look back at the beginning of the PowerPoint. I just want you, like, after going through this, well, what do you think like the main thing was that we were trying to accomplish here? Okay. And what you learned. So make sure that you add those in. Please do not add those as comments in the assignment, because I don't always see those, okay, efficiently. Make sure they're part of the document that you hand in. Does that make sense to everybody? Okay, so I want those 3 questions asked or answered. If you don't, that's really important to me. It's kind of a way for us to kind of debrief, if you would. It also lets me know if I need to go into any detail on some more stuff. Okay. So what I'll usually do, I'll always read those and I'll give you a little bit of feedback in my comments back to you when I grade it. So you can even ask me a question there if you want to. I've had people do that too. Or you might even say, I hope you don't say I didn't learn anything in this, but you might say, I don't feel like I need any additional practice. I feel confident in what we did. You can say that too. You don't have to just try to make something up. Just be honest with whatever your answer would be to those questions. And then I have some notes here about submitting. So first of all your diagrams have to be in AutoCAD. No sketch diagrams. If you wanted to add it as part of the mobility equations like I did when I showed you the work, that's fine, but you have to have the AutoCAD diagrams. Also show all your work for the mobility equations. Remember the equation in variable form first, then add your values in, and then show me the final answer. And then make sure that when you take a pic or a screen snap, I can see everything. So something I want to call to your attention is when I do my, when I figure out what my colors are on my layers, I used white for object line, I used hatch yellow, and I used the magenta for the notes because I can see that. Okay, it's easy for me to see and make out especially when there's a dark background. If you choose to use other colors, that's okay. You don't have to do exactly what I did here, but make sure that they're bright enough so that I can see them. I've had students before, like, for instance, if I put my notes instead of in pink, I put them in blue. believe it or not, they're really hard for me to see when you try to hand that in because it blends into the black background when you do a screen snip of it. So try to avoid dark colors on dark colors for me, if you don't mind. That just helps me to see it a lot easier because if I can't read it, I can't give you credit. Okay. So, so make sure that you do that. They're having lots of fun over there. Don't you wish you were over there? We should. But, so any questions kind of on the AutoCAD screen snip, that type of thing? Okay. Also make sure that you label your example here. And I've had some students ask this, can I put all of my kinematic diagrams in one document and then just screen snip them separately? Sure. Okay, that's fine. So then you would probably save your file as the practice problems assignment as opposed to each of the individual examples. So that's totally up to you how you want to handle that. Additionally, if you wanted to, I hand wrote the mobility equations underneath our camera here, but you could also, some students have been adding the mobility equations and typing them into AutoCAD here, and they're right with the screen snip. So you can feel free to do that as well. Okay. But make sure you check it each time. I know it's an easy cut and paste, but make sure that it's correct because there's going to be one at least that isn't going to be one. Okay. It's going to be something else. So, so if you copy it, I'll know that you weren't checking. Okay. So any questions on the practice problems? Okay. All right. So then the other one that I want to look at then is going to be the other assignment that we have, which is assignment 1, part 1. So I'm going to click on that one. Now you're going to notice here that it looks really long. Okay. But there's actually, I think, just 6 problems here. The first 6 diagrams that I'm having you do here, those are the only diagrams that you're going to do. And then the 6 mobility calculations coincide with each one of those. It's the mobility for each one of those diagrams. Okay. So 10 points for the kinematic diagram and then 5 points for showing me the calculation for the mobility. All right. So let's go ahead and look at the problems that we have at the end of the chapter. And then I'll kind of give you some insights on some as well as see if there's any questions as we're glancing at things. So the first one that we have is going to be problem 1-1. This is on page 25. Okay. And it says we have a mechanism that's used to open the door of a heat treating furnace is shown down below. Draw the kinematic diagram for the mechanism. The end of the handle should be identified as a point of interest. Okay. So we're going to do that same process that we did before. If you wanted to draw a sketch to start off with, go ahead. You don't have to hand in the sketch, but you are responsible for the kinematic diagram on AutoCAD. Okay. Using those standard symbols that we've been using. So as we look here, you're going to see that this is the handle. Okay. It is attached to the outside of the furnace right there. So that's going to be the point that it's going to rotate around. Then on the end of that handle, you're going to notice that there is a link that goes down to the door. And the door then is going to slide vertically up and down. Okay. So that you can get parts, I guess, in and out. So, so that's the mechanism. As you look at it, are there any questions that you have in regard to this first one? Okay. The next one that we have is going to be 1-3. This is a folding seat at a stadium. You want to draw the kinematic diagram for this mechanism. Okay. So in this case, we've got the seat at the bottom. We've got 2 links that are in line with one another. So these are 1, 2 links, and there is a pin connection between here. Okay. And then this is going to flip up and down. All right. So it's going to rotate about this point here. And one of the links is located or it's going to be connected at this point here. So you want to identify where is the frame. In this case, the frame is going to be the attachment to the wall where it sits. So anything that's there is going to be your frame. And then the kinematic links then are going to be, you know, simplified based on what we see here. So does anybody have any questions as you look at this one? Turn the page. The next one that we're going to do is a toggle clamp. This is number 1-9. Very similar, but not identical to the one that we did for the example problem. So you can use that as a guide. Okay. And then you're also going to have to do then the corresponding mobility equation. Okay. Questions on this one? All right. The next one, 1-10. This is a child's digging toy that is commonly found in municipal sandboxes is shown. You want to draw the kinematic diagram for this mechanism. I'm going to give you a clue on this one because usually this is something that students are like, how do we draw? There is a bar here that is like a T. Do you see that? This is all one. So it's kind of hard to make it a triangle because it's kind of a different type of a shape. So the suggestion that I would give and how I would do it is I would start with my frame down here because this point is not moving. So my frame is going to be right there. And then I would go straight up to the top of the handle. I would come down, kind of leave a space. Then I would go out, back, and down. And then you would have a pin connection here. Okay. And a pin connection on the very end. And then you can draw it that way. The book lands a lot on just triangles, but if you need to make it a little bit different shape, as we've seen in a couple examples, that's okay to show the extents, but also to give the idea when a part is continuous. If you would put just a straight line between two pin connections and then a triangle here, it would look like two separate pieces. Okay. So you have to get the idea that it's one continuous piece that moves together. All right. So that's usually helpful because some students are just kind of wondering how to do that one. So that's that. Any other questions as we're glancing at this before we move to the next one? So kinematic diagram in AutoCAD, labels, and all the good stuff. The next one that we have is going to be 111. The problem statement's at the bottom of the previous column, but the illustration is up here. So we've got a reciprocating saw. We want to show the kinematic diagram of the mechanism that we see there. Now, in this one, there's like a flywheel here, and it's a circle. At the center of that, it's really a motor that's there. And it's connected by the radius, if you would, down to that first link. So to illustrate this, all you would do is this would be the frame member at the middle. Okay, so at the center of rotation here would be the frame because that would be staying stationary. And then you're just going to draw, instead of the circle, you're just going to draw the radius of it to the pin connection for the link. Does that make sense to everybody? So you simulate it as just a radius as opposed to the full diameter, the full circle. So the radius is not a link. The radius is a link. It is. It's just that we're not going to draw the full circle. Yeah. Mm-hmm. And then up here, the blade is going to go horizontally back and forth. So that's going to be a slider. Okay. So any questions on that one? All right. Turning the page. Our last one is problem 124. So on page 28 in the first column at the bottom is the problem statement, but immediately down below it. So you're going to do a sewing machine. This is not a sewing machine. The sewing machine diagram is up here. Okay. So this is where the diagram is for it. This one again, as it goes around, there's a little flywheel here, but the center of rotation is going to be at the center of that flywheel. And that would be your first frame member. And then you're going to notice that you're going to draw it just like that previous one. This is just going to be a radius or a link straight to the connecting rod. And then you're going to have a slider going down. Okay. Does that make sense to everybody? So similar, but a different operation. So what's kind of cool is you'll start to kind of see how these different mechanisms, you know, even though it's a simple 4-bar mechanism, we use it over and over again in a lot of different configurations to do a lot of different jobs. Okay. And then connections are a little bit different. Configurations are a little bit different. But it's kind of fun to see, you know, how it all comes together. So diagrams for each one of those. Those are 6 diagrams for each one of those problems. Then each one of the problem statements for 26, 28, 34, 35, and 36 are calculating the mobility for each one of those problems that we just did, okay? So you're gonna do 6 diagrams with 6 corresponding mobility equations or calculations, 10 points for each one of the diagrams, 5 points for the calculations, okay? Then there's 2 more to do. There's 2 case studies at the very end of this chapter. The first case study is going to reference this feed device that we see down here, automated for ball bearings, okay? And then you're gonna look at the diagram. You do not need to make a kinematic diagram of this. You're just looking at the diagram, you're getting some insights on how it operates, and you are gonna answer the 6 questions down below. Now, this is the deal. You guys are in your 2nd year. We're getting you ready to kick you out of the nest. So you're gonna be going out in industry, you're gonna be, doing your thing. What I want you to do is, instead of answering these questions with 1 or 2 word answers, I want you to answer them in complete sentences in a way that I don't have to reread the question. So for instance, the first one says here, as link A rotates clockwise 90 degrees, what will happen to slide C? To answer that, instead of just saying it's going to go to the left, okay? I want you to answer it so I don't have to read that question again. So I want you to say slide C will move left, right, I don't know, whatever it's going to do as link A rotates 90 degrees clockwise. Okay, so a full sentence. I want you to practice being able to communicate your ideas in written form, because it's going to be something that you're going to have to do on a regular basis. Okay, I'm not looking for a novel. I'm not looking for this big deal. 1 sentence, but I want the sentence to be complete, and I want it to fully answer the question so that I don't have to read it again. Make sense? Okay. All right, and you're going to do that same thing for 2 through 6 as well. The other one that we have here, I'm going to turn the page, should be a familiar mechanism. It's the mechanism. This is a version of the mechanism inside of a toilet tank, okay? And you can even go and look at home and see how yours is configured either the same or differently than what you see here. So this is the illustration or the diagram. You don't need to draw it in AutoCAD, but you're going to reference that to answer questions 1 through 9. Again, each of those answers needs to be in a full sentence in a form that I don't have to reread the question in order to know what you're telling me or asking for. Okay. So that's your assignment. So if we go back to assignment number 1, part 1, then you are going to be handing those in with the 2 case studies. There aren't any questions to answer here. Those are always going to be just part of the practice problems, not as part of the assignment. And then you're going to upload that to the Dropbox. And that's it. These 2 are due at the end of this week. So that's in just a couple days. That's their first due date. But remember, you still have a 7-day grace period after that to get it in and or corrected for full credit. Okay. So that is all that I have for today. Are there any questions before I let you guys work independently? No. So let's look at the calendar. I'll stop the recording here.